This is question number 11. I'm starting where the prompts help you draw the picture. Place the power supply above the beaker. This is an electrolysis setup, therefore no spontaneous reaction occurs. The power supply must force electrons to move. I'm arbitrarily choosing plus on the left and minus on the right. You could do it the other way, it's fine. Once you do that, however, it determines the flow of electrons. Here is the way you think about it. You decide if there were an electron here in the wire, which way would it go? The plus attracts electrons. The positive pole of the power supply attracts negative electrons. That's why I drew the arrow going in this direction. The minus on the other side pushes electrons away, repels electrons. So this is the electron flow. Now, B says, put the salt solution in the beaker. Sketch the salt as dissociated ions. It'll be dissociated because it is a solution, a salt solution. It is aqueous. The text tells you what salt it is. It says 90% of the chlorine is generated from the electrolysis of sodium chloride solution. Sodium chloride solution. Those ions are dissociated. All right, there's a representation of the sodium chloride solution. C says add H2O molecules. Those may also react. Water molecules can be oxidized. Water molecules can be reduced. All right. The next prompt is using the word anode. Anode is the site where oxidation occurs. Oxidation is the loss of electrons. So you have two choices. It's either this one on the left or it's this one on the right. Where does loss of electrons occur? Hoping you see it's related to the flow of electrons. So here on the left, electrons are moving away from the graphite. Here on the right, electrons are moving toward the graphite. Loss of electrons is occurring on the left side. Something in the solution is losing electrons that then go pulled up the graphite to the power supply. All right, so this is the anode. Anode, which means the other side is the cathode. Next to the anode, write a half reaction for the chemistry. Must be an oxidation. As I'm looking for something that can be oxidized. The graphite itself cannot be oxidized. The sodium ion cannot be oxidized. Water could be oxidized. Chloride ion could be oxidized. The whole purpose of this setup is to make chlorine gas. Make elemental chlorine. So this is how elemental chlorine is made, through an oxidation half reaction. It is negative potential, but it's okay because the power supply might be a 5-volt power supply, and that will make it happen. Next prompt, next to the cathode, write a half reaction for the chemistry that occurs there. We've already decided cathode is on the right. It is the site of reduction. What can be reduced? Not chloride ion. not the graphite itself. Choices are sodium ion or H2O. Sodium or H2O are capable of being reduced. In this case, the water will be reduced. You saw the reduction of water in your mini lab, electrolysis mini lab. That's what the electrode that turned pink from the phenolphthalein. So here it is. It's negative potential, but it's much, much less negative than the reduction of sodium. Sodium ion is horribly negative. Negative 2.71 volt potential is not going to happen if there is water present. So water is reduced at the cathode. F says graphite is an appropriate material for this anode. It's a graphite anode here. Why would copper be a poor choice? Because you want to oxidize chloride ion. This is the desired oxidation half reaction. The goal is to make chlorine. If you used copper as the electrode, copper could be oxidized instead. And the potential for the oxidation of copper is negative, but it's a lot easier to oxidize copper than it is to oxidize chloride ion. All right, chlorine gas, G, chlorine gas is produced right here on this electrode, right here on the surface of the electrode. Bubble, 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 bubble. If this were an industrial setup, it would be produced at a prodigious rate. Lots of chlorine gas being produced, and it would need to be captured with some kind of hood here. Capture the gas and purify it. The last question, where is sodium hydroxide produced in this diagram? Okay. There won't be NaOH stuck together, but there will be sodium ions that are spectators. And we have seen that this half reaction for reduction produces OH minus. So at this electrode, OH minus will be produced from the water. So that's how you get sodium hydroxide, OH minus produced at the, well, produced via reduction of water. So when you run this, you're essentially having the chloride ions will disappear from the bath. They become gas, and in their place will appear these hydroxide ions, and when that's gone on for a long time, the solution will be filled with sodium hydroxide.